Hello everyone. Thanks for taking time to attend this section of SusiCon. My name is Angel and the CEO of Shunyou. You're probably wondering what the two Chinese characters mean. In the purest way of translation, it means purest, and even in that sense in English. You may be wondering what is the unique word. No need to Google and look it up for you. I give you translation in 6 words: excellence, unparalleled, exceptional, swift, instant, real-time. And those words describe the Shunyou platform I'm here to talk about today. Definitely, I will talk about our partnership, our speed to market, and what our product does on the market as well. I really have two key elements to go over today: why and what. So here is a quick agenda. Why Shunyou was founded, and what SWOT analysis I gave, and who is value using this platform. And I want to talk about our platform a little bit. In terms of the cloud solution, why it's intelligent, why it gives way to your intelligent platform and all your platform and all, and to figure out a collaboration synergy to work with your system directly. Last, I like to talk about how cooperate our platform with SUSE overall, how we scale through SUSE. Honestly, everyone in the last 3 years have had their business in critical situations and critical challenges. From this as a base, I felt like I needed to create solution platform that help my business back home in China, as we are struggling to getting through our challenges that business could not get the people on ground. The people could not get what they needed, and at the same time, they were struggling to just stay healthy. I did a SWOT analysis of the situation. I need to understand in the current opportunities I have, what were strengths, weakness, and threats. Because all three of those things would kind of summarize whether my opportunity was proper, what are my opportunity to go through this market in such a tough condition, would help me thrive in a scenario when very innovation was available in my own country. So in the last 3 years, I think we have couple things in common. The world was unprepared. We are scrambling for survival. A lot of foundation of what we built in the last 25 years was kind of torn without a warning, kind of like a tornado just scraped through our land. The key is we knew that a lot of the business struggled. A lot of business could not work as usual, and they needed new innovation to continue their business. All you know, they would not easy to exist. But technology was the key highlight. Technology helped humankind accelerate communication when we were all still stuck within our four walls. This is when I saw an opportunity to find a foundation help business struggle, and instead of scrambling to survive. I was focused on seizing an opportunity to build a platform that would help challenges in my home country thrive in a difficult situation. We built and seized this opportunity. I want to share this with you today. What is my SWOT analysis? Let's start with the weakness. That's on the right. There was no budgets, economic downturn, supply chain slowdown, right? Competition. I'm pretty sure when we were all stuck at home, everybody is thinking, what is the next solution? What is the next thing that's going to come out? How would the solution be able to adapt to a limited environment where it could be little to no help? And the threat of when the economic does recover. How is the solution and the platform also scale and grow with it? So, as a Chinese person, when I grew up, we were taught by our parents to think on what's the bottom line of feeling and finding a solution. This is how we brought up. But as I explore the world, I learned about stress and opportunity. I learned that there were a lot of businesses that were in reactive format. So I needed to create a platform of strengths where I could take an existing platform, no matter how old or how outdated, make it easy for them to change, easy for them to adapt and embrace our real time. Because to be quite honest, anything that is not real time now, because of what happened in the last 3 years, took a toll on our patients. The opportunity obviously C is my favorite section of this analysis. Is that from the new little experiments, from the little demonstrations, from the little proof of concept I did with a lot of the large companies in my region. I found that our data platform could proactively show what are the broken silos in our systems when nobody was looking at the system from a working standpoint. A lot of platforms reacted to manual intervention. So when something happened, the system had to wait, and somebody else had to come in and do something to it for things to work out. I needed a platform so that without the manual process, it could be a proactive life that gives feedback. The minute somebody requests for the manual communication was something I felt was too slow in access. We were just lacking the real of the entire economic, where I could envision a scenario where everything was proactive, everything was remote, and we could be able to signal how to improve our ecosystem without us finding it in the last minute. As we all know, in the last 10 years, my home country has completely digitalized into a format of everything was through the phone for device or through anything the digital. The value prop was the next thing I thought of outside of the solution because you can come up with a really good solution but it doesn't address the value. So our company is really around our focus on. Our platform was around instant. It was about optimization. It was about bringing wisdom and having the intelligence. I think we can all agree that AI has extremely expanded and scaled in the last 6 months beyond all our imagination, whether it's text or text to image. So when I was developing the solution, I didn't think of the solution from the ground up. I thought from the customer standpoint. There are many solutions out there that is able to find a customer challenge, probably being real time. But that finding the problem is like 10% of the challenge. Fixing it, providing a solution for, is a part of other time spent on it. So the very proposition I had to think about was from a platform solution point. It had to be instant, optimal, provide wisdom, and be intelligent, as we live in the era of AI. But at the same time, I needed the system to focus on certain things when we would provide professional services, maintain a solid reputation so that we would have ongoing business with our current clients and also attract new clients. We would have practical innovation. So a lot of times when the platform is put in place with our customer, if there was something that was missing, it would provide the wisdom and intelligence so that we can continue to innovate because we are a platform with great reputation that goes through a lot and connect to a lot of systems. Providing decision is not just that we have to be able to provide a timeline of how things will be fixed and also proactive. We will have use case later on to show if how is use case work with our value purpose. And I will get there. The last thing was that was really important for myself was attracting the right talent to work at the company. As you can imagine, the last 2 years the economic was tough, work was tough, but the tech talent was always available. There always abundance of tech talent, and I had to think of creating a platform, one with the latest technology. Two, would attract the top talent so that we would continue innovation as we progress our products. Let's jump into the platform when we thought of Peerless. We thought of obviously cloud engine real-time addressing data, and it had to be a platform that could scale. We wanted to enter a solution that was complete. It could have anything missing parts. If there was anything missing, we could connect to it. Comprehensive support from like cloud to near edge to working literally at the edge was very key for us because we wanted real time to be in the middle seconds to happen at the moment of time, not having second melted and escape away and enabling the real-time sensing. The process of analysis was really important because all that allow us to have real-time decision making on the spot and to have choices made for us in a proactive manner. We want to connect everything. That was Internet of Everything, not just Internet of Things, because everything was clearly needed to be connected so that we would address all the challenge all at hand. With all this together, we empowered and implemented this digitalization in some of our key customers back home. So here is a quick look at the business architecture of what we want to address. We want to address things in data layer. We wanted to have analysis so that you could see what happens with the data. Data is only useful when you could understand it. We want to provide feedback at the business tier so that how would the data and analysis help you optimize your business and ensuring that your back office ERP, for example, would have the ability be updated and using a future working manner. On the other side, we wanted to connect to anything like big data platforms and the Internet of Things platforms. And having all that understood inside with a rules management engine that would connect everything all together. I'm CEO of the company, but my technology team was able to work with the SUSE team to put the solution architecture that would help us all scale together. As you can see by myself, as you can see for yourself, we have abandoned our technology with SUSEs, and this is our way to partner with SUSE to scale with SUSE altogether. Let me explain how the Puris real-time data platform solution architecture looks like. As you can see in the diagram, we have three layers of intelligent computing platform starting from a centralized cloud data center and extend to a geographically distributed edge locations which control various sensors and mechanics for automation. These layers are interconnected with various network protocols ranging from the 4 or 5G network, Wi-Fi, Aurora, NB-IoT, to name just a few. It is a centralized cloud data center part. This is the heart of the Puris Cloud platform. It served as a core intelligent rule-based engine to orchestrate how various devices at the edge side should respond to the conditions of the environments surrounded based on data collected from numerous sensors at the edge, and it also gives real-time analytics report for management to ensure their operations will keep going on smoothly and things are fully under control. It's a it's a mission critical control plane where it cannot afford any downtime. As such, SUSE has been working together with my team to put this control plane to run on a self-healing, auto-scalable Kubernetes platform managed by Rancher to provide secure data persistent cloud-native storage long haul with secured volume encryption was also adopted in this control plane. Container security control are also enforced by NuVector in the hardened Kubernetes and the Celeste Linux operating system, which comply with industry recognized security standard like a CIS benchmark. to ensure the manageability of the Peerless Cloud Control Plane. Rancher, a centralized Kubernetes management platform, is implemented as a single pane of glass for the entire cloud-edge Kubernetes infrastructure. It integrates with Peerless Cloud's existing infrastructure, like their identity management services, monitoring and SIEM tools, as well as their own CI/CD DevOps toolchain to provide a properly secured, traceable control plane for audit and the capacity plan, and automate application updates from their software development team. The whole control plane is running on a cloud-native hyper-coveraged infrastructure harvester, which gives them flexibility to scale as well, simplified and standardized operation for both virtualization and container technologies. At the edge side, they have two key components as well. They are near edge intelligent all-in-one device and the edge intelligent gateway. The former aggregates metrics collected from the edge gateway devices and provide AI intelligence to process and analyze the data and take actions based on the rules defined in the cloud data center to control multiple devices at the edge. These all-in-one device and intelligent gateways are small devices that has a relatively small compute capacity. As such, Celeste Micro was developed to power up these tiny devices. The near edge all in one device has high availability capacity powered by K3S with encrypted data persistence provided by long-haul, and the containers on the edge are secured by NeuVector. The edge intelligent device, however, is a tiny box that has less than 1 GB memory to fit the containerized application of these tiny edge devices. Podman is used to run the edge application on such tiny box, which works very well with the near edge intelligent all-in-one devices. With such architecture, Rancher is used to manage all Kubernetes clusters across edge in multiple locations. All workloads running on the edge can be updated through the use of the GitOps approach with Fleet provided by Rancher. Likewise, all the Linux operating systems, including SLAS and SLAS Micro, are regularly patched and upgraded centrally to ensure all the edge environments are properly secured. We will show you a demo of how the system works together now. In terms of use cases, this is sort of the foundation of how we started the company. We need to find things that require the response time and lack the response time and lack the intelligence to tell what actually happens on how some of the platforms you could really have. As an example, we had a company at back home that had their power stations down and the very least at the moment of time they couldn't provide the feedback to the system to say that so it was ours. After there was a natural response. Having that connect to our system, first of all, allowed the proactive alerts to be alerted to keep personal, and also connected to the real-time engine, allowed the engineers to be on site at the quickest possible of time, providing them recommended solutions to fix this problem right way. We felt that providing choices for people allow even the most odd hours of time to have them work at optimal efficiency was very key important for us. And here is a quick look at one of our key customers that we've been working at. Here is in the center. What they have here is called a smart converting system. It's an energy platform. It connects to hundreds of different devices. And as you can imagine, at any point of time, there's a possibility that something will not be communicating back and forth. Our solution ensures that communication is happening and that if there's anything stored, anything stop working, any of the meters that is not functioning, maybe they're out of battery. Anything that's not flowing data back and forth, providing the analysis and the choices. We would allow the team and the company to know that there's something that's not happening right here. Here's a possible scenario of what's happening, and here are the solutions on the part that could help ensure that the systems all are running and going at the same time. As you get around, here's some scenarios of alarm system and the fire protection system. System, if kept running at the real time, could help prevent a lot of tragedies from happening. So let's jump into the demo time.
We are now demonstrating the first scenario. During sensitive times, entry or approach is prohibited, and the entrance is simulated through an external photoelectric sensor. Now I am using my hand to simulate personnel entering. At this time, you can see that the sound and light alarm is triggered, indicating that it is definitely a sensitive time. We enter the application program and first look at the first node on the left. The logic here is responsible for judging whether it is an infrared photoelectric sensor in the direction of entry. Data begins to flow in, which is the data I simulated using my hand entering during sensitive times. It will trigger an alarm and report and record the number of incidents. Let's take a look at the first node on the right, which is responsible for judging the sensor in the direction of leaving. Leaving will not trigger an alarm, but will be recorded as leaving the area. Now we come to the cloud, where there is an application program that is mainly responsible for enriching abnormal information and saving it to the big data platform and sending exceptional information to the person in charge via SMS. The event stream configuration is a topic, and the abnormal information enrichment node is configured with a program. We can open the program to see the logic inside, which calls the service interface of the big data platform for abnormal ID queries and then fills the data and returns it. We continue to the node that saves the exceptional information, which is also a program that stores data through a service interface call. Data begins to flow in. Let's take a look at the format. After enriching the abnormal information, the data looks like this. We can see that our data has been successfully stored in the big data platform. Finally, we come to our SMS sending. Here, the SMS source is bound and the configuration object is specified. Back to the Edge page, there is a client on the right. Clicking on Relieve Alarm will turn off the sound and light alarm. We can use low-code development to design a simple page to display which devices are in alarm state and provide the function of turning off the alarm. Now we change the alarm node in the cloud scenario from the entrance to the door opening and update the deployment. After reloading the Edge project, the Edge application program is also synchronized. We simulate personnel entering again, and the door lock is opened. Abnormal data flows into the cloud. We can see that the data is composed of parameters such as ID number, abnormal value, and exception ID. After data enhancement, error information is added to the data, and finally, the exceptional data is saved and sent. Let's go to the big data platform to check the abnormal event information table, which shows that the data has been successfully stored in the database. Next, let's take a look at our table and table structure. The personnel access statistics table is mainly responsible for storing the personnel access information of the entrance and exit devices, consisting of device number, status, and event. The abnormal event information table is mainly responsible for storing information about external devices that have anomalies, consisting of device number, device value, exception ID, abnormal information, and scenario events. The error ID information is mainly used for abnormal information enhancement, consisting of ID and error information. We are now demonstrating the second scenario, where photos taken through a camera are used for card verification in our system. The photos enter our application program, and the card verification function of the Big Data platform is called for verification. We go to the Big Data platform and can see that the function call was successful. We prepared 4 ID card photos, but only one passed because the ID number allowed to pass was already stored in our system. Therefore, the data in the card that passed is correct. In this business scenario, the data and management platform provide 3 core capabilities: data collection, data management, and algorithm models. Let's log into the Data Lake Management Platform interface and go to the Personal Portal homepage to find the Intelligent Substation Management project. First is data collection. We can see the basic resources at the bottom, which include the registered data storage managed by the Data Lake database, including the Intelligent Substation database and S3 stored in the platform. The database contains 3 tables drawn into the data lake by the EDP system. Taking the abnormal event information table as an example, we can view the data management level. The management describes the data resources from the technical business management dimension. You can see the top directory bar of the interface and directly view the basic content, business attributes, function attributes, technical attributes, etc. of the data table, adjust its field information flexibly, and perform row and column level network control. Establish certain data standards to manage the data. There are also detection reports for data quality, and it also supports providing data services to external parties. The configuration of sum, add, delete, and query field information of the table is available. There are also bloodline relationships and entity relationships of data resources, as well as macro detections. Second is data management. We can see some dimensions of data management level from the job orchestration independently developed by the data service platform. First, enter our job, and you can see that the entire process includes data detection, missing value filling, time field processing of the abnormal event information table entered into the lake, and data routing to different locations. Next, we run, first reading the data table and branching management according to specified conditions. The third part is algorithm models. An algorithm model refers to a series of calculation steps used for specific problem-solving methods, commonly used in applications such as data processing and automation decision-making. The platform can support existing algorithms, registered in the form of program packages and function interfaces. In the current business scenario, identification of personnel identity information needs to be realized, and the algorithm model of card identification can be used. After deploying the calculation program to the near edge end, which is the machine scene, cloud data aggregation can be achieved, and data processing can be performed at the near edge. Next, let's take a simple existing data file as an example to execute a function. Under synchronous call, uploaded pictures and their basic information can be accurately recognized. Secondly, from the second dimension, since a large number of pictures cannot be clicked when imported into our S3 storage platform, we can convert the identity information stored in S3 into structured text and store it in the table. The entire process is shown in the figure. Next, we run from S3. There are currently 2 pictures, which are encoded in base 64 and parsed by the card identification function demonstrated just now. And finally, the person's identity information is resolved and stored in our MySQL database, and JSON can also be directly stored in our MySQL field. The above is the demonstration of data collection, data management, and algorithm models of the Data Lake Management Platform in the business scenario. So, in order to support such a set of cloud edge collaborative application architecture, we have some infrastructure professional problems that need to be solved urgently, and this is the time when SUSE plays a key role.
In this demo, we're going to show you how the PLS real-time data platform is using Rancher to provide not only a reliable Kubernetes environment for them to run, but also how easy it is for them to scale to manage not only the workload on the cloud, but also on the edge as well. So in this demo, you can see that there is this cloud environment running this platform, and then here's the edge. If we look at the cloud environment here, I simply click on it, and then I can simply get into here to see all the microservices running on this cloud platform. Now, similarly, it also has the application that is running on the edge to give the intelligence to collect the data at the edge, to analyze the data on the edge. Now, this is running 1.1 here, as you can see, this edge server. Now, imagine it has multiple edge here, and then now what it has been done is they want to upgrade this EDP server, edge server, from 1.1 to 1.2. How can they do it in one shot to ensure all the edge cluster without human interaction to update them manually at every edge site, which is far remote and expensive to send the engineer to do the upgrade? How can they do it easily and quickly? With the Rancher-based approach to manage all the edge cluster, they can simply use the GitOps approach to do it. This is what we call the continuous delivery in the module. Now let's take a look. This is the continuous delivery, and as you can see here, I've defined an edge cluster to deploy the application onto the target cluster group. Now this is the target cluster, and if I look at here, I include all the edge cluster based on the matching label, and then it will be included here. Now in this demo I have 3, but you can have hundreds or thousands of them. It's just scale. And in certain cases, we have some environment running to 1 million clusters at that kind of scale as well. But for now, we just define the application that we want to deploy to. In this case, we point to the deployment manifest in here. If I look at the definition, so I just give a name, I deploy from this Git repository where it contains the deployment manifest. If I look at here, it will look like this. This is the application that I need to deploy to. And currently it's deployed with version 1.1. As you can see here, I just define everything, and then I want to say, okay, the deployment should be targeted to all the edge clusters that I'm targeting to. In this case, it's those 3 clusters, and it should be deployed onto the target namespace running as dev. So this is how I define it. And then now, with this defined, in case you have the new application update, it's simple. The CI/CD environment that you have will then simply update the newer version in here in the deployment manifest, and then you say you update it in the Git. Now you see what will happen is that in here in the definition here, it will try to detect the changes made in the Git, and then it will process it and propagate all the changes by downloading the new image into every cluster, as you can see here. Now this has been done. It's all updated the resources, and let's take a look again at one of the edge, and then what I can see here is now the image has been upgraded and it's running successfully. This is how easy it is for Rancher to manage the cloud to edge environment by simply giving its capability to update the application at the edge at scale. In this demo, we are going to show you how to use System Manager to manage all the Linux operating systems that is used in the Peerless real-time data platform. So let me log in as an administrator, and then I go to the systems. I'll be able to see all the list of the system that it has been included for patching. So as you can see here, they have different Linux operating system ranging from the traditional SLAS system, and then there are SLE Micro over there. And with System Manager, you can also include any kind of popular Linux distro, including the Rail, Ubuntu, CentOS, to name just a few. So with this tool, we can have a full list of the servers that we need to manage the security patches and the packages as well. Now, if I need to look at one of the patches, I can take a look at here. This system, the cloud platform, it has running SLE 15 SP4, and then you can see that there are 49 patches that are pending for patch as well. If I click on this number, then I can easily see which kind of patch that I need to apply onto it. There are a different type of legend that we can see. Some of them are bugs, some of them are the security patches, so we can see here which one that we want to apply to and which individual component that is applied for. So if I look at here, I want to say, let's update the firewall D component. I can simply choose the particular patch, and then I can easily say apply. Then you will ask me to confirm, do we want to apply it now, or you want to schedule it later in the maintenance window? And these are the related packages that it will be applied to. So we can confirm it if we want to do it now. For showing you how easy it is, then I can simply click this confirm button to schedule to do it now. Then what it will happen, the system will simply schedule the 2 patches updates on this selected box, cloud platform, to do it. So if I look at whether it's applied or not, I can simply click this events tab, and then in the history, and you can see that it's going to update the patch that we have selected on that particular box. So you may take some time to complete it. Right now it's already updated. If I go back to the system list again, then you can see that instead of 49, there are 46 pages. Instead of 48, only 46 patches that are left to be applied onto this box. So with this central view of the patch management system, we can easily identify which box that we need to apply, and then we can control how and when it should be applied here. So if we want to take a look at the proper way of doing this, sometimes you want to test it out before you apply it, then System Manager also gives you the capability to do it. So that is called content lifecycle. Let's take a look. So this is the content lifecycle that we can define to only systematically to apply the patches to a group of servers. For example, here in the Preless real-time data platform, we have the edge servers that we need to apply to. And then we can say, okay, we just select the target servers, the edge systems. They are using this kind of Sleep Micro as the source channel for applying the patches to the target clusters. So we can even further filter which particular set of patch that we need to apply to. For example, we can apply the patch that is released before the beginning of this year, and then we can filter them to apply to it. Then to apply to it, we can define the environment to run it first, and then we can, before it's promoted, to release it to the production systems. So all this can be managed through this content lifecycle in order for you to comfortably test all the patches available from the vendor before you apply it to the production system. This can help you to improve the manageability of your whole patch management process. So that's the end of this demo.
Okay, so let's jump back to the slides. So as we talked about working with SUSE and embedding in SUSE and scaling through SUSE, I like to talk about how we work together to extend, scale, and simulate what it can happen with SUSE, making our entire ecosystem a lot stronger than it currently is. So I guess everyone definitely sees the business benefits for Pure's real-time data platform empowered by SUSE Edge technology stack. First, the entire architecture is made simple and easy to operate through platform standardization and automation. For example, applications running on cloud and edge can be provisioned and upgrade without a description without through the use of Rancher Fleet. Kubernetes and OS are patched and upgraded in automated manner through the combined use of Rancher and SUSE Manager. Together with the use of NeuVector, it minimizes the risk of cybersecurity threats at both the cloud and the edge levels. With fully automated operation at the edge, there's no longer a need to dispatch expensive skilled engineers to onboard or maintain the systems at the edge location. So significantly saves the costly resources in the edge environment. The most important part of this solution is through the core value of open source technology. Not only it helps to avoid the risk of having vendor lock-in, it also helps to can innovate through activity participation in the open source community with industry leaders and end users to foster technology innovation and have a long-term vision of on technology sustainably. So here I'd like to conclude with how peers will be connecting and proactively providing suggested into the following ecosystem, acting as a communication bridge in digital world, offering you the best digital experience. Obviously, we have the back office CRM initiatives that are connected to. We have your big data with data system. We can connect with public data. We also work with anything across natural language, AI, ML, and computing AI, video, sound, GPS, movement, mobility, anything that affects real-time systems we want to connect to. Our platform will ensure that everything runs through not only smoothly, but everything runs up optimal real time. I was always say, life is not easy until we make it easy. And through SUSA, I believe that our partnership will only make things better for the world. Thank you for your time.